Welcome back. We just learned our first notation, O of n, or linear time. And we see here that we have a few others remaining. So let's talk about the next one. Another very common big O notation that you're going to see. What happens if we have a function like this? A function that says compressed first box that receives an array of boxes. And this function simply has console.log boxes 0. So that is, it's logging out just the first item in the box. What would you say the big O of this function is? How many steps or operations does this function take if the boxes increase from 0 to maybe 10, to maybe 100, to 100,000? What would happen here? Ready for the answer? Well, this is what we call constant time. It's an O of 1. That is, no matter how many times the boxes increase here, or however many boxes we have, we're always just grabbing the first item in the array. If we look at this with an example, if we had an array of boxes here, and we run it through the function that just takes the first item in the array, well, the number of operations is 1. No matter how big the number of boxes are, we're only doing one thing. So it's a constant time. If we look at this on a graph, if we have one element or one box, we do one operation. If we have 3, again, we still do just one because we're just grabbing the first item in the array. If we have, let's say, 5, same thing. 7, same thing. And what about 9? Again, same number of operation. And this is, I don't know if you can see the line, but this is just constant time. It's not linear time like it was, where it increases and increases with the number of operations. The number of operations just stays flat. But I have a question here. What if we do something different? What if we do something like this? What if we have a function that says function grab or log first 2 boxes? And this takes an array of boxes and it's going to console.log the first item in the array, and it's going to console.log also the second item in the array. How do we measure the big O of this function? Well, let me just comment this out for a second because we don't need this right now. And just create an array called boxes. And this boxes has, let's just say 0, 1, 2, 3, 4, and 5. So 5 items, or 6 in this case, because we include 0. And if we run this function, log first 2 boxes, and we give it the boxes array, and we click run here, we have 0 and 1. So we've logged this one and then this one. What's the number of operations here? Well, we have O of 1, that is one operation here, and then we have over here O of 1 again. Each time, this function runs 2 operations. So this function in total is actually running O of 2 operations every time. So no matter how big the boxes get, the number of operations here is going to be 2. If we look at this on a graph, instead of having O of 1 like we had before, we have O of 2. And then if we had 3 operations, it'll just be O of 3. But overall, it's still a flat line. And this is something we're going to get into later on. But when it comes to constant time, we don't care about the nitty-gritty O of 1, O of 2, O of 3, O of even 100. We round this down to just simply saying O of 1. That is, we have constant time. It's a flat line. In terms of scalability, it doesn't matter how big our inputs are. We're always going to do the constant amount of time on a function. And if we look at this on a graph, we see that O of 1 over here is the dark green area. It's excellent. We love O of 1 because it's very scalable, right? It doesn't matter how many elements we have, it's always going to run the same. Predictability when it comes to computing is very, very nice. And O of 1 is definitely excellent. Okay, so we've learned about linear time, O of n, and then constant time, O of 1. Let's do a bit of a fun exercise to really solidify our knowledge here.